Sorry, I was trying to get my iPad going today. Apologize for the couple of minutes. Trying to get it ready. Hi. I haven't seen like you in almost 2 weeks. That's crazy. So we are going to talk about a few homework problems because there were definitely a lot on the list for me to kind of look at and go over, which I kind of expected. I kind of had this day built in as like a question and answer day for us to think about the problems in section 2.5 with the fundamental theorem of algebra. So we're going to kind of go over those. And as you can see, your homework for today is just some extra problems on section 2.4 and 2.5. So section 2.4, 4 problems, and that deals with just complex numbers, operations of complex numbers. And then section 2.5, I have a couple of problems there, continuing to find the zeros using synthetic division, the rational zero test, find a polynomial if you're given the zeros, or find a remaining zero if you're given the imaginary zero. So we're going to look at some of those problems and try and work through them together. Before we do that, though, I wanted to take some time to go through some of your 2.1 to 2.3 test. So if you actually want to pull out your test, go to Google Classroom and find your test. Everybody at home, do the same thing. So if you can go to Google Classroom, pull the version that I edited. So when you go to Google Classroom and click on the test, this is the 2.1 to 2.3 test. Get the edited version that I had comments on, because there's a couple of questions that I do want to talk about so that we can kind of clarify some things before we think about taking another test or you completing a retest. So if you want to pull out that test, and then we will look at those homework problems. So as I said on Tuesday, you have a chapter 2 test next Friday. So all of the concepts from chapter 2, and we only have 2 more sections to complete. And those 2 sections deal with rational functions, and they aren't nearly as involved as a polynomial function. So we're going to be looking at fractional functions, but they aren't like algebraically as involved. So the first question on your test, this one was pretty good, finding all the parts of the quadratic function using completing the square to take that function and place it in the standard form. And then number 2, I think after like this section that we're covering again, finding zeros of a polynomial function means looking it up in the calculator, using synthetic division, and breaking it down. So I think that question will be pretty good after we've gone through those concepts again. But it's question 4, which apparently was supposed to be 3, but I don't know, I skipped 3, I guess, when I was writing it. Wants you to determine the value of k such that x minus 2 is a factor of the polynomial. And then it gives us the function f of x equals x cubed minus kx squared plus kx plus 2. No, thanks. Oh, she's right there. No, that's fine. Yep. Thank you. So this question is more of like an application problem. Can you take the concepts that we learned in class? Can you use the information and the properties that we talked in class to go above and beyond? And that's how a lot of this class is going to be. And that's how calculus is going to be. So you learn concepts to apply them to bigger things. So let's first talk about something being a factor. Darby, how do you know x minus 2 is a factor of a polynomial?
If it's a 0 on it, like whenever you
Yeah, so if something is a factor, it means we should have a remainder of 0. So we need to use that fact. And when we use synthetic division, we have to you have a remainder of 0. Darby, what would we be dividing by then? We would divide by positive 2. So if you're using synthetic division, we are going to divide with positive 2. Now it says use synthetic division or the remainder theorem. I'm going to show you both ways. So if I use synthetic division, remember we take the constant or the coefficients that are in front of all of the exponents. Well, my x cubed has a 1. My x squared has a negative k. I'm going to keep that negative k in there because that's what we're trying to find. And then there's a positive k, and then there's a 2. That remainder is supposed to be 0. So we did a problem similar to this, where we had a square root that we were dividing with, but the process is very similar. So I would bring down the 1, and then we would multiply. 2 times 1 is 2. And then we add, and if I add 2 and negative k, I get 2 minus k. The problem that we had a square root of 3 in it, and we would add a number and the square root of 3. So Jeremy, what would you do next in this process if we're continuing synthetic division? Yeah, so I have to take whatever's on the bottom here and multiply by that number in the circle. Well, that means I'm taking 2 times 2 minus k. And if I do that, I get 4 minus 2k. And then, Jeremy, when you add k and 4 minus 2k, you end up with 4 minus k. And then you do that process one more time. So I'm taking 2 times 4 minus k, and I end up with 8 minus 2k, and then you add them together. So if I add those two together, 2 and 8 minus 2k, I get 10 minus 2k. Well, that's supposed to be equal to 0. My goal is to determine k, which means I need to find the value of k. That would be the coefficient of my x squared in my x term. And if I solve for this, I end up having k to be 5. Some people that got it, I think, just spent a lot of time using guess and check and finding a number that worked. So that would be one way of solving the problem. But there is a second way, and that's by using the remainder theorem. Because I can use synthetic division and get a remainder, but we also can take that same value of 2. The remainder theorem says when I take this value of 2 and plug it in as a function, that would be equal to whatever my remainder is. Well, when I think about a function and I have a value of 2, that 2 is my x in the function. So I have this function, and I'm going to replace the x with the value of 2. That's what the remainder theorem says. So in my function, I have x cubed, so now I have 2 cubed. I have minus k times x squared. I have plus k times x, and then I have plus 2. So synthetic division, I kept the k as the coefficient. The remainder theorem, I'm replacing x with its value. And then if I work through this is an 8, this is a 4k, a 2k, and a 2. Combining my like terms, I end up with negative 2k plus 10. Notice it's the same thing that I got from my remainder. So based off of the remainder theorem and what Darby said, if it's a factor, the remainder is supposed to be 0. So that means this needs to equal 0. And that is another way that I could then solve for k. So again, it's taking what we've learned and going above and beyond and applying it. So using those concepts we talked about in class. We did talk about a problem similar to this where we did the remainder theorem and plugged in numbers. And we talked about that value being an ordered pair or having that remainder of 0 to be a factor. So application problem, going above and beyond. There's another application problem on this same page, and that would be number 7. Number 7 is a quadratic application. And we did a few quadratic applications. There was the football problem in your book. There was a maximization problem in your book. And then you had a worksheet that had actually a maximization problem on it, a high dive problem on it where you were diving off the diving board. And then there was the infant problem. So we probably did 6 or 7 quadratic applications in section 2.1. This one wants us to find the number of units x that produces a maximum revenue. And then we have this function here, 900x minus 0.1 x squared. It says, what is the maximum revenue? Justify your answer. And then it says, if you use your calculator, list the window and tell how you found this value. And then I put in a hint. Think of the two ways that we found that value in class without using a calculator. I think as a student, you see the fact that you're allowed to use a calculator and you think the calculator is the easiest way. This one here, I actually think the calculator was the harder way. Because when you graph this, you got a line. Because the numbers in this problem were so large that you had to find numbers big enough to get it to graph correctly. If you take a couple of seconds when you look at a question to just focus on the equation that they're giving you and think about what that graph is supposed to look like. Grant, if it's 900x minus 0.1x squared, what type of graph would that equation give us? Why do you think it gives us a parabola? Yeah, and it's a parabola that goes down because it's a negative x squared. So this function, if I write it differently, it's really negative 0.1x squared plus 900x. But because it's an x squared, it's a parabola. There is a maximum of a parabola, and that maximum occurs at its vertex. So if I want to find a vertex algebraically, we talked about doing two different things. We talked about completing the square, which for this problem actually works kind of nicely. And we talked about using a little formula to find that vertex, to find the axis of symmetry. Does anybody remember what the formula was that you could use to find the axis of symmetry? It was a fraction. Darby? Yeah. So I could complete the square by taking out the negative 0.1, factoring that out. Or I could find the axis of symmetry by taking negative b over 2a. And if I do that, I have negative 900 and then 2 over negative 0.1. Way easier than trying to get that graph to be in your calculator because the minimum and the maximum values had to be in the 10,000s for you to kind of get that whole graph to fit. Whatever you get for X is the number of units. Whatever you get for Y is the revenue. So calculator is not always the easiest thing, but I think like if you see, oh, I'm allowed to use a calculator, I should just do that. Sometimes it's not the easiest way to work through a problem. The last one that I wanted to talk about, my hopes were that this last problem was like the easy peasy problem of the quiz, the last two really. So number 9 was just listing the possible zeros. So in my mind, that's like 4 free points. I even made it 4 points. That's just P over Q. And number 10, we have a graph and we're trying to give the equation for the graph. And again, I thought like this should just be 3 easy points. So they get 7 easy points to end the test. But instead, I guess it was like one of the hardest problems because everybody kind of forgot about the parts that it meant. What was going on with this graph? Well, it's going down. They give you the zeros, but one of those zeros is special. Evan, which one of those zeros is special? You're looking at that graph. Why would I say 1 0 is special? Why would one of those zeros be special? Yeah, at -1, it doesn't go through the x-axis. It touches it and it curves. So if I'm looking, the one in the middle definitely looks different than the ones on the left and the right. If it goes through, it's a single root. If it crosses or touches and bounces the other way, then it's a double root. So the fact that we have x equals -3 and then x equals -1, that's a double root. And then my final one is x equals +2. But that double root as a factor means that it's a quantity squared. So this is an even graph because both of them go down. Even functions either go up or go down. I'd say at least half of the students thought it was an odd function, but an odd function splits. It does the opposite. So odd graphs do the opposite. Evens do the same thing, up or down. And then the last part, because both pieces go down, that means this has to be a negative function. So I must have a negative sign in front there. But if you miss the fact that it was a negative, and you miss the fact that it was a double root, you did lose 2 points because that was like the biggest part of the problem. Kind of understanding that it's a double root because it curves and it goes down. That's the end behavior part of the function. So I wanted to look at some of these problems because yes, you're going to see them again on the chapter test next Friday. But also, you have the option of doing the test corrections and then retaking this test. Those test corrections are due by Tuesday. So now you kind of have at least an idea as to what you should be doing for those test corrections for some of those problems. Does anybody have questions on that? All right, so I would like you to take out your homework now. So if you could please find your homework, we are going to look at a few problems from the homework. I'm going to start with 28. I think that was the first question that was asked, probably by 5 different students, 6 different students. So we'll start with that. We're going to do number 62, and then we're going to look at number 69. So we're going to try and do 3 problems, the 3 different types of problems that we would have looked at. So number 28, the directions wanted you to find the zeros, all of the zeros. And that's pretty much what this section is. The fundamental theorem of algebra says find all the zeros of your function. They could be real, they could be imaginary. And then I copied the notes that we did yesterday where it says, how do we find zeros? Well, we could graph them and find the real zeros, use the rational zero test, use synthetic division, factor, or if my equation is maybe not factorable, I might just have to solve by taking maybe the x to the other side. If you graph this in your calculator, were there any real zeros for number 28? You plug it in your calculator. Evan? Say it again? 1/2 was a real zero? I don't think there were any real zeros. I think the graph should have looked parabolic, like a parabola. And I think it vertex is above the x-axis, so it kind of just goes up. Pretty sure that there is not any real zeros for this problem. So looking it up in the calculator isn't going to help. Using the rational zero test isn't going to help. And using synthetic division is not going to help. But the last part says to factor or solve, which is actually how we started the class yesterday. We took those 3 problems that we solved them, we factored those 3 original problems. Number 28 is factorable. So not everything involves synthetic division and the rational zero test. If I look at this, I have x to the 4th plus 29x squared plus 100. This is the trinomial form. Yes, I know it's an x to the 4th, but it is in the form of a trinomial. And if I have a trinomial in the form x to the 4th, x squared in a number, that means I can factor it with regular traditional factoring. So then the question becomes, we have a 100. What are the 2 numbers that multiply to be 100, but add to be 29? And are 2 numbers that multiply to be 100 and add to be 29? 25 and 4, positive or negative? Positive. So if I want to factor this, I have x to the 4th. She told me 25. That's going to be an x squared because my 29 has an x squared. And then she also told me 4. And then I have 100. So the middle terms are x squared because my middle term is x squared. Those 2 numbers are supposed to add to be 29. So then, Hannah, if I take a GCF out of the first pair, what could I pull out? And if we take a GCF out of the second pair, we would pull out a 4. And it's a plus 4. This expression needs to remain addition. It can't just disappear and become a multiplication problem. It's a positive 4 because I still have these 2 expressions. This plus sign is still dividing my problem up into 2 separate expressions that I'm pulling a GCF out. So then I end up with x squared plus 4 and x squared plus 25. Again, the question asked us to find the zeros, all of the zeros. So now that it's factored, Grant, how could you find the zeros once I have this factored form?
You just solve for x.
Yeah, solve for x. So x squared is equal to negative 4. Grant, when you take the square root of negative 4, what does that make?
Plus or minus 2.
Perfect. solve for x. X squared is negative 25. Grant, when you take the square root of negative 25, you get, how many real answers do you have here, Grant? 4 imaginary ones, yeah. 4 imaginary answers. There aren't any real answers because the graph doesn't cross the x-axis. When you're solving for x, you're finding zeros. Why does the graph cross the x-axis? Well, if it doesn't cross the x-axis, then they're all imaginary. If I was asked to write this in factored form, I would just take each of those zeros and place them with x. So I have 1 at plus 2i, 1 at minus 2i. Those are those conjugates that always occur together. I have 1 at plus 5i and 1 at minus 5i. I still have 4 zeros, but they're all imaginary this time. So don't forget about the factoring part. That seems to be like, oh, I don't need factoring anymore. But that's like the basis of a lot of the things we do in algebra and pre-calc. So factoring is still there. Might be the last option if you're kind of check marking. Can I use synthetic division? Is there something that I can look up in the calculator? And if you say no, then factoring is like, okay, that's the way I'm going to have to solve the problem. Questions on 28? All right, so we're going to go then to 62. The directions for 62 wanted you to find the real zero or the remaining zeros given one of the zeros, one of the x-intercepts. And the one they gave us was -3 plus I. So our goal is to find the other ones. Yes, you could look up them in the calculator, but then the calculator's doing the work and you're doing nothing. You're just letting the calculator give the answer, which I know like that's what you want to do. But then you might as well not be in this class because like, what's the point of learning math if you're going to just look up everything in the calculator? At least that's what I kind of think. You guys probably don't think that. So if you have -3 plus I, Brenna, without doing any work, what will be another 0? Yeah, those are conjugates. They occur together. You can't have one without the other. So always together in a pair. The middle value, the symbol that's in between, that operation, one has to be plus, one has to be minus. So Brenna, could you place those in factored form for me? Nice. And I can still see that these are conjugates. Let's go with this. Here is the x plus 3 part, that's the same. The conjugate part is that plus and minus. So these are conjugates. We are going to use these conjugates and FOIL them together so that I can get an equation that they would have come from. And when I FOIL them, we're going to take this whole x plus 3 because that's the real part of it. We're going to group them together. So that's actually my first term. So x plus 3 times x plus 3. Well, if I'm FOILing them, multiplying them together, there are 2 of them combining together. My inner terms are going to cancel with my outer terms, so I'm not going to write them, and that happens with every single conjugate. But my last term would be a negative I, or a positive I and a negative I, which makes a negative I squared. So again, I'm trying to find the equation that these zeros would have come from if I was doing it the other way. So if I FOIL this, I get x squared, 6x and 9. A minus I squared is really a minus -1, so that turns into a positive 1. So if I was given the equation x squared plus 6x plus 10, that equation would give me these 2 zeros. The zeros were created from that equation, x squared plus 6x plus 10. But our goal is to find still the other missing 0. Yes, you can check it in your calculator to kind of help you so that you're checking your work. But how could I use this equation to find the other remaining 0 algebraically? Darby? Right, so we're going to take this equation and what we started with. Our goal is to get our original function to break down, to give us whatever happens to be missing, that extra 0 that we don't know. That's the goal. And if we use long division, we can find that remaining 0. So long division says compare the first term. Darby, I have an x squared. We need to make it 4x cubed. So I would multiply it by 4x. And then you take that 4x and you multiply it by the entire expression, x squared plus 6x plus 10. So 4x cubed, 24x squared, and then 40x. And then that gets subtracted. That whole quantity is subtracted. So this is a minus 24, and that's a minus 40. So Darby, what do you have left when you subtract them? And then Darby, I have an x squared. I need to make it a negative x squared. So that would just be, right, a minus 1. So if I multiply that entire thing by minus 1, negative x squared minus 6x minus 10, subtract, you better get a remainder of 0. Because whatever answer on top here, that is your remaining 0. I know that because now my remainder is 0. That's my quotient, my leftover answer to my problem. So 2 of the zeros were really given to us. One was implied, the other one was there. My last 0 is the real 0, and that's at 1/4. You can look that up in your calculator to check your work. Make sure that you did it correctly. Plug that graph in the calculator. It should have 1 real 0 and only 1. And that's the real 0 because the other 2 are imaginary from the 3 that I have to work with. Questions? As a math teachers like problems that involve multiple concepts. Because I can give you this question on the test, and I'm checking, do you know long division? Can you do foiling? Do you realize an imaginary number occurs in a conjugate pair? So like, those are just 3 concepts in one problem. So that means I can give you 1 problem instead of 3. 1 problem is testing multiple things. Great type of problem to kind of think about. Anyone at home have questions on this problem? So there's one final problem that I wanted to go over, and that was number 69. Here it is. 69 would be the problem that we're going to try and apply these 3, 4 pieces to. Because it's not factorable, so I'm going to have to graph it and find the real zeros. We're going to have to use the rational zero test, use synthetic division, and then we're going to try and solve it or factor our remaining answer. So we're going to try and do those pieces for this last problem. And it did give you in the directions. It said part A was to look up a 0 in the calculator. And then part B was to find the other zeros. So let's look that 0 up if you haven't. Jeremy, do you have a 0 for number 69? 1/2? I got something different. Anybody get something different, or everybody got 1/2? 3/4, 3/4, 3/4. Check it again, Jeremy, just to make sure. So first step in your calculator, and Jeremy, you might have just plugged the wrong, like one wrong number, might have just given you something. Yeah. So in your calculator, we're finding one answer. There's just one of 3/4. And then the next step would be to take P over Q. Well, here's P, there's Q. It's going to be a pretty long list of numbers, and I'm actually going to skip writing that long list of numbers. But this would be 1, 3, and 9. And this would be 1, 2, 4, and 8. The 3/4 is going to be in that because I have a 3 and I have a 4. So I would have a list of numbers here. And then after you find that 3/4 and you kind of proved it with that P over Q part, Hannah, what do you do with the 3/4?
You use it and divide the synthetic.
Yeah, so we're going to use it and divide with synthetic division. So that would be the next step. So 8, negative 14, 18, negative 9. Hannah, what is 3/4 times 8? 3/4 times negative 8? 3/4 times 12. Remainder of? You get a different remainder. Remember, you did something wrong. It's okay to have a fraction up there. We're allowed to have a fraction. It can't be a random decimal. It can't be irrational. So we started with 8x cubed. This is now 8x squared, negative 8x, and 12. So 8x squared, negative 8x plus 12. That's my remaining polynomial. What could you pull out of 8x squared minus 8x plus 12? Hannah, what could we pull out of there?
Positive 8.
A positive 8? What's a GCF there?
Oh, 8. 4.
A 4. Yeah, it's okay. It's all right. So I could pull out a 4 and get 2x squared minus 2x and then plus 3. Makes the numbers a little smaller. Checking factoring, because that was the last step. Can I factor? Well, I pulled out a GCF. 2 times 3 makes 6. Those are my factors of 6. Hannah, what's wrong with those factors of 6? None of them equal negative 2. Oh, snap. None of them equal negative 2. That means I can't factor it, but you still have to find the zeros. And Jeremy, I think I asked you this question last week. If you can't factor it, what's the option? Quadratic formula. So my only option is to try and use the quadratic formula. It's a long problem as it is. And now I got to use the quadratic formula to find the other zeros. So we know 1 0 from the calculator is 3/4. The quadratic formula is going to give us another 0, actually 2, my 2 remaining zeros. So remember negative b squared, 4ac, and then 2 times a. Use the smaller numbers. We already factored out that 4. Use the smaller ones. It'll be easier to work with. Sorry, I shouldn't write in green. Green's kind of hard to see, huh? Grant, can you see the green okay? Yeah, okay. My non-HD screen up here makes it a little blurry, but I guess it works. Someday I'll have an HD screen when HD doesn't exist anymore because it's something else. So underneath that radical, what number do we have underneath there? Anybody know? Negative 20? Yeah, because that's what 24 back there. This is 4. Yeah. Uh-oh. Answer key said something different.
Or it might have been that you have to do all the 4.
Yeah. So when we have the square root of negative 20, just like a regular square root, we have to break it down. So it would become 2 plus or minus, the square root is 4. Of 4 is 2. The negative makes the I, and then we have the square root of 5. Mrs. Kane gave you an evil problem. And then the last thing, I'm going to do a little crisscross simplifying here. 2 divided by 4 becomes 1/2. 2i divided by 4 becomes 1/2. And then you've got the square root of 5. So when you're simplifying, you're taking the 2 on the top and dividing, 2 on the top and dividing. That's how the back of the book got its answer. So again, like a very hard problem. It has a lot of steps in it. Do you remember what to do when you can't factor something? Oh, that evil quadratic formula, which comes back to haunt you. Probably every other week in this class, or at least once or twice a month, which would be every other week, I guess. Questions? I'm guessing that homework probably took you a little longer last night than maybe some of the other assignments that we had to do. So there are about 5 minutes in class. I'm going to pull back that screen so you can kind of see what the homework is. It's coming. This is in your book. The first 4 problems should hopefully be pretty straightforward because those first 4 problems are just the complex operations. The next group are identical to the ones that I just went over. So please, look at the ones that we did together in class. The goal is for you to kind of practice those and feel more comfortable on those problems because you're going to see some of them on chapters 2 test on next Friday. And as I said, tomorrow we're going to totally flip directions and talk about rational functions. Did I answer everybody's questions? If anybody have general questions? Anybody at home have questions? Is everybody okay at home? Did everybody fall asleep on me?
No questions.
I'm good, Miss Kim.
Oh, good. Okay. I just wanted to make sure everybody was there. All right. So if you're at home, have a great rest of the day. Thankfully, it's sunny today. I feel like yesterday was dreadful. I'm not looking forward to the Pittsburgh next 3 months of gray, dreary weather that we're known to have. But I just thought yesterday was blah. All right. Questions? Yeah, I'll come over. Have a great day, everybody at home. We'll see you tomorrow.
Thank you. Have a good day.